So Sarah asked me to talk about all of the things I'm seeing in the smart city space and cram it into 15 minutes, which is impossible, by the way. So if anyone wants to see the much longer but much more boring version of this presentation, feel free to come find me at lunch and I'll figure out a way to share it with you. So to walk through some of the tech that we're seeing in the smart city space, I'm going to walk through a couple of real quick project examples where this stuff has actually been implemented over the last couple years, and then talk about some of the things that we're seeing implemented right now. So the first project example is in Japan. It's a town called Fujisawa, actually the Fujisawa Smart Sustainable Town. There are about 1,000 homes in this community, and it's mostly built, actually opened a couple years ago. And the first lesson I would like to impart is I work for a technology company. You should never start with technology. So this is supposed to be about disruptive technology, but the most disruptive technology that I think we have is actually our brains. We need to start with good planning, common sense, creativity, and really don't provide technology for a problem that doesn't have to exist. Try to solve these things through good planning. So Fujisawa is a great example of that. How many people remember Hurricane Irma having to scramble to the grocery store to get food? And what was that fun? It was horrible. I hated it. So Fujisawa is actually planned out for this. The community center actually stores several days of food for the entire community. So imagine if the next hurricane is coming to Florida and the little community center in your neighborhood already has food stored up. You don't have to go through that nightmare waiting in the grocery store for canned goods and water. Also from an energy perspective, I work for a company that sells lighting and air conditioning, but we intentionally laid out the homes to collect natural daylight, to collect sea breeze, and actually eliminate and minimize a lot of the air conditioning and lighting. So through good planning, we can address resiliency, energy, and other things without having to do technology first, and it's a lot more cost effective. And then once we get through good planning, now you can start to really figure out how to use technology to fill the gap. So some of the technology you will see in Fujisawa, if you're ever in Japan, every home there is basically its own microgrid with solar power and battery storage. So if there is a natural disaster, you can actually disconnect from the grid. You have your own home energy management system, and you can operate while the utility is down. How many people lost power for about a week during Hurricane Irma? It was really hot then, too. It was not fun. So in Fujisawa, you've got the backup power. Transportation as a service. You don't need your own car in Fujisawa. If you want a car or you want a bike, you can go on your phone and use one of the community bikes or cars. So transportation as a service. Does anyone here like waiting in the doctor's office? Raise your hand if you do. It's terrible, I think. It's a great place to get sick. They're always running late. So in Fujisawa, we've actually set up a telehealth system, so you can actually visit your doctor from your own living room. And that book you see there is actually not related to Fujisawa, but it captures a lot of the same concepts. And I actually got a copy of that book from a major healthcare provider that has multiple hospitals in Central Florida. So this stuff, I think, is coming to the US as well. So that's just a brief touch on some of the tech at Fujisawa. Next case study project is Pena Station. This is actually where my office is in Denver. This is about a 382-acre mixed-use community that is just starting to come out of the ground. There's a train station in my office right now, and a apartment that has started construction, and a hotel that's about to start construction. So one of the things from a technology perspective, smart street lights in an open IoT platform. So everybody hears about smart street lights and the amazing amount of stuff that you can just pile onto a street light to make it really smart and sense all kind of things. But the real key really gets into the platform and making sure all of those sensors can actually talk together, work together, and be used for real services. So, you know, it's coordinating multiple city services into what platform, or actually making the city be able to talk with a building through an open platform. So as an example, we have gunshot detection on the streetlight. So if somebody shoots a gun outside, I can actually send that signal inside the building, and we can do things with that. We could, if somebody shot a gun outside here, we could put the building on lockdown. We could make a message over the PA system and have it actually be instant through an open platform. Autonomous shuttles. So we have autonomous shuttles. Unfortunately, most of the people I work with are a little bit insane, so they always jump in front of the autonomous shuttle to make sure that it works. So it's kind of this like start, stop, annoying ride, but they work. And we're using them. We're starting to change the regulatory space a little bit so that we can use these to better connect bus stops with train stations. All the hotels by my office all have their own shuttle that goes to the airport, and it's like a 15-person shuttle that usually has one person on it. So we're looking at using these autonomous shuttles to better link the hotels to the train station and actually alleviate traffic going into the Denver airport. So autonomous shuttles, and I think Orlando might be starting to look at these. Vehicle to everything software platform. So this is really just another open IoT platform. Most self-driving autonomous cars that you see today, they have sensors and they can sort of see the cars around them, but they're not necessarily communicating. So this is really the next phase, and it's actually mostly built right now for a test run on I-70 in Colorado. So this is a platform that takes all the data from your car. So if you have a new car, I don't know if you realize it, but there are thousands of data points available from your car. But they're not really leveraged for the community right now. So this system, the car will actually, and it'll be mandatory in a couple years, that your car can actually communicate with these software platforms. These software platforms are being built right now, and then that data can be used by the rest of the community. So for example, if I'm driving down the highway and I blow a tire, there is a sensor in my car that senses that the tire just lost pressure. It can actually communicate that to the streetlight. The streetlight can communicate that to your car 2 miles behind, so you know something just happened out in front of me. And there are so many applications we are thinking of for this. And the most important thing is quite frankly, trying to eliminate just about every traffic death you can think of through an open IoT platform. Carbon neutral planning and clean and resilient electricity rate structures. So our neighborhood in Pena is carbon neutral already. We are master planning it right now to be a fully carbon neutral 382-acre development. And we are not trying to disrupt the utility. We are actually partnering with the utility. We think the utilities actually have an opportunity to sort of disrupt traditional development cycles. So in Pena, what we're doing is we're actually working with Xcel Energy, the utility. We're working with NREL, National Renewable Energy Labs, and we are building new tools to link utility analysis with building analysis. So a lot of people here have probably done an energy model of a building to try to predict how much energy you're going to use and when you're going to use it. So we've now actually worked with NREL in a program called UrbanOp to actually link all of the energy models for our neighborhood into one collective, roughly 400-acre energy model. And we've now linked that to the utilities feeder and substation modeling program. So what's happening is, as I decrease energy 1% or 2% on my own, a lot of times that may not make economic sense. But if I can get to a tipping point where the utility doesn't have to buy a new substation or increase the size of their feeder, it saves them a lot of money. So we're creating a partnership with the utility of, if we can do certain things in our neighborhood and it avoids utility infrastructure, will you reinvest it in our neighborhood? And they have. So the utility actually provided that battery. That's a 2 megawatt hour battery. It's the phase 1A battery in our neighborhood. And it actually gives us resilient power. So it created this circle. So most commercial buildings have a standby diesel generator. We got rid of ours because we use the utility battery. So I actually saved money on my building. I'm actually arguing before the Utilities Commission that I should pay the power company more. So we've created this carbon neutral infrastructure and everyone is actually making more money out of it. So that's Pena. So some of the other things we're working on right now, a lot of people have probably seen smart glass, where it's basically an internet connected piece of glass and you can change the tint. That is just the tip of the iceberg. Once you make it a connected device, you can do all kinds of things, from having your window be a television to using your window for drone warfare if someone's trying to spy on you or take pictures of you, to these smart mirrors. So this smart mirror, this is actually at one of our R&D facilities. I was testing it once, and I mean, it's like a big iPhone that is a mirror. I was actually trying to find a place to get dinner that night in the New York area, and was trying to pick a buffet, actually, and the mirror can actually see me. So it's pretty much said, really, buddy? Let's see if we can find something more healthy for you. So it's kind of embarrassing, but it knew I was a little overweight. But you're going to see a lot of intelligence embedded in glass. Smart parking. Most cities actually have more parking than they need. The problem is that it's not networked together and it's not really talking together. So you're starting to see smart parking systems inside of a garage. Now the real trick is connecting all of those smart parking systems. So you may have city parking lots, you may have 100 different private parking lots, and when we start to connect those into one platform, you can now see, you can use dynamic pricing, you can use wayfinding, you can find a parking spot a lot faster. You may be able to find one cheaper if you're willing to go further away. But the real key is, I think this is going to start to unlock the ability to build new buildings without parking. So we're starting to test this theory in different markets of, why do we need parking? There is plenty of parking. Can we use technology to link to the parking infrastructure that's already there? Lighting as your smart building platform. So my personal opinion is, all the sensors that you see on the wall right now, you'll see thermostats and occupancy sensors and carbon dioxide sensors. There are many lighting companies that are starting to embed all of that into the light. And what happens now is you have all these different systems. You have a fire alarm contractor put in some sensors, an HVAC contractor put in some sensors, and they're all separate systems, and then they sort of integrate them at the end, and it doesn't ever really work right. What's actually happening is all the sensors get embedded in the light. The light is becoming the smart building platform. It is becoming the sensor network to drive the building, and that is going to unlock a million things that I could spend all day talking about. But one of the ones that we actually really like that we're seeing in the market, and this is not something that we're doing, are some of those manufacturers actually starting to embed open software into it, so like Android. So this could basically turn your building into a smartphone. You have a smart building platform embedded in your lights, and you can actually write your own apps to customize your building, as opposed to being, using sort of old legacy kind of closed control systems. Voice command. So everybody's seen like Amazon Echo and Google and the little speaker, and that's all sort of do it yourself. We're starting to see this be incorporated into sort of a more commercial scale. So imagine walking through your office building and being able to talk as you walk in the room and say, I'm hot or I'm cold. That is actually very, very close without having to walk around with the Amazon speaker. And then last, but certainly not least, you hear a lot about artificial intelligence and machine learning, and it's actually quite powerful what a lot of that can unlock. One of them is actually specific to electric meters. So we're actually testing this on our building right now. So you can actually put one electric meter on your house, and through artificial intelligence, it can learn the signature of all the devices in your house. So it can actually tell if you left the refrigerator door open, all from one meter. And I think that's going to be huge in sort of the real energy efficiency world and energy savings and the commissioning world, to be able to use one sensor and machine learning to do what used to take hundreds of data points. So those are some of the things we are seeing in the smart city tech space, and I will be around at lunch if anybody has questions.